Alright, so in this question we're going to find the smallest distance between A and B. So that's what we get if we draw a line straight between A and B. To do that we can use a right angled triangle. If we draw a right angled triangle here at some point, if we find the lengths of these two sides, then we can use Pythagoras' rule to find the shortest distance. Alright, so the first triangle that we could make is what we get if we extend the line CD, and if we look at this smaller triangle here. So if we extend that line, it was by definition perpendicular to this other one, because that's how we constructed the triangle. So if this side length here is 4, well, first we should look very kindly, the question's given us an angle, so we know this angle is 150, so this angle in here must be 30 degrees, which makes this angle in here 60 degrees. So that's very useful, because now we can see if this whole length here is 4, usually in our 60-30 triangle, if I draw it over here, so normally for this, if we start with the side length of 2, and opposite the 30 degrees is 1, and then root 3. So here let's do that, except that opposite the 30 degrees would be half of the length, so that would make this length 2, and the perpendicular height would be whatever that is times by root 3. Maybe it's clearer if we talk about 2k, k, and k root 3k. Alright, so now we can make another right angled triangle by dropping a perpendicular line here. And let's look at this triangle here. We have a 45 degree triangle. That's another one that we're familiar with. We know that the sides are equal, and if this is 8 root 2, dividing by root 2 means that this side length here is 8. So this is 8, but also we've made a rectangle so that this opposite side here is also 8. And so this is really good, because now we've found the length of this side is 10, just 2 plus 8. So now all that's left is to find this length, and we can find that by looking at the big line here. I think we can do it on this diagram. Let's just look here. Let's look at this distance here. We know that we've got this distance here is 8. We have this distance here is 2 root 3. So the bit in the middle we would get by subtracting 8 root 3, subtracting 8 from 8 plus root 3. So that means that this distance here would just be 8 root 3. So adding these two lengths together to get our side length, we get this as 10 root 3. Hopefully, it's a little bit smaller diagram, but hopefully you can see it on your paper. So now to find the length of AB, as we said, we're just going to use Pythagoras' rule. And so let's go ahead and do that. 10 squared plus 10 root 3 squared. And so this is going to simplify to 100 plus, well, maybe if we put all this in, I should also include some safety brackets here. All of this is squared. So that means we've got 10 squared, but also the 3 squared. So this is going to be 10, or 100 I should say, 10 squared is 100, times by root 3 squared, which is 3. So that's going to make 300. So the length of AB is what we'll get when we take the square root of all of this, which is 100 plus 300, which is 400, which we all know is 20. There are units given in this question, and so we should include units in our answer. Great, well I hope we enjoyed that question, and we'll see you again in another video. Bye for now.